So electronic distance measurement we have to see now. So it is a method of determining distance between 2 points, two stations through use of electromagnetic waves. So we may have different kind of instrument which are, e- electronic distance measuring instrument, and they use the principle of electronic distance measurement, in short EDM. Now, what these instruments do, they use electromagnetic waves. Okay, now what are electromagnetic waves? Now we all know that about the waves: radio waves, X-rays, gamma rays, infrared rays, visible light. These all are part of electromagnetic waves. Okay, so electromagnetic waves have different frequencies and different wavelengths. According to that, they have different energy, and according to that, they have different name. Some frequency range is gamma wave, some frequency range is X-rays, some frequency range is infrared waves, like that. So these electromagnetic waves, how they are created? So they are created due to the vibration between an electric field and a magnetic field. So as the name says, electromagnetic wave, so there has to be two fields. One is electric field and one is magnetic field. Due to the interaction between these two fields, we have electromagnetic waves. And these electromagnetic waves has a property that it travels with a constant velocity of 3 into 10 to the power 8 meter per second in vacuum. And there is no air. In presence of air also, this velocity is approximately this value, but there may be few differences depending upon, you know, the air, the elevation, the material, if there is, it is passing through solid matter, like that. Okay, depending on that, this value may change, but this value will be approximately closer to 3 into 10 to the power 8 meter per second, which is also the velocity of light, right? So the light is again the visible portion of electromagnetic wave. Now this is how they are represented. We have an electric field, we have a magnetic field, and because of their interaction, we have the electromagnetic wave. Now, I hope we are accustomed with these terminologies. What is the amplitude? What is the uh, wavelength of a wave? So, if we have a wave like this, the length between these two corresponding, or two, adjacent crest, that is going to be our wavelength, right? And this is our amplitude. Whatever is this value from the mean position, that is going to be the amplitude, right? That way we have different terminologies to characterize the properties of the wave. Now this is called electromagnetic spectrum. Here we see different rays. We have gamma rays, we have X-rays, we have ultraviolet, infrared, microwaves, and radio waves. They are classified according to the frequency, according to the wavelength. In these range, we have shorter wavelength. When the wavelength is shorter, what will happen to the frequency? Wavelength and frequency are inverse to each other, right? When the wavelength is shorter, that means in a given second, remember, their velocity is same. They're traveling with the same speed. So, if the wavelength is shorter, the number of completed wave in a second will be more in this region, right? And in this region, wavelength is longer. So what will happen? The number of completed waves in a given second will be less. Now the number of waves completed in a second is frequency of that wave. So in this region, frequency will be higher, right? In this region, frequency will be higher, and in this region, frequency will be lower. So whenever the wavelength is smaller, frequency is higher. Whenever the wavelength is longer, frequency is lower. So here it is written high frequency region and low frequency region, and in between here we have visible light. So this entire wave, different frequencies and wavelengths of waves together, they are called electromagnetic spectrum. Here we can see all the ranges of frequencies and wavelengths. Then what is the principle of electromagnetic distance measurement? We will have one instrument, just like shown here. We will have one instrument, and electromagnetic waves will be transmitted by this instrument. And if we have another signal, another prism or some instrument which can receive this electromagnetic wave, then what we can do? We know the velocity. The simple principle that velocity is equal to what? Distance by time, right? So we know the velocity. If we can measure the time, we can find out what is the distance traveled. That is our intention to find out. Our intention is to find out the distance. Somebody saying something in the group? Okay, so very simple. The first principle that we are saying, very simple. We have our instrument here, we have our instrument over here, we have another, this is going to be a prism which will reflect the energy actually, because what we have to do, this has to come here, it will hit here. We need to measure the time of travel. Okay, and it is easier to measure this time of travel here only. Okay, if we can do it here only, it will be easier to measure. So this principle, what we are doing here, we are using a reflector here. Okay, this reflector will reflect the energy or the wave back to the initial instrument. There we will see the time. We will calculate the time. We will calculate the time. Now the distance. We have the same formula that yeah, sorry. Okay, my mouse is not working. We have the same formula. Velocity is equal to distance traveled by time, and in this case, the distance traveled will be twice of d. Why? Because it was reflected and it came back to the original instrument. All right, so distance travel will be twice d, and the time required for this travel is t, and we can find out the distance from this simple formula if we can calculate the exact time of leaving the instrument of the electromagnetic wave and reflected back to him. However, what happens, the time is very short. So measuring the time taken is actually difficult because it is traveling at a very high speed, 3 into 10 to the power 8 meter per second. So the time required for traveling to these normal distances will be very, very small. Okay, it goes so quickly. So therefore, it is not so easy to measure the time. So we have a different method of calculating the distance between 2 points, and that is by calculating the phase difference. Now, what is phase difference? We will see what is phase difference, and we know this formula. We know this formula of the basic wave connecting the velocity of the wave, the frequency of the wave, and the wavelength of the wave. And we also know that frequency f is equal to 1 by d. Okay. Now, what is the phase? So when the wave starts, say it starts from here at this A point, this B point, C point, and D point, say for example, it completes one wavelength. Okay, we will know one wavelength is completed. Next, how much it goes before it reaches a particular point. Okay, it may be here at F point, it may be somewhere here, it may be a G point. Okay, so there is phase. So phase is a particular point in time on the cycle of a waveform measured in angle in degrees. So when it completes an entire wave, this is okay, this has traveled, it's like 360 degree. It has made a complete circle. Okay, so it is written here. So at A point, what is the phase? 0 degree. At B point, what is the phase? 90 degree. At C point, 180 degree. Half is completed. At D point, it is uh, yeah sorry, at C point it is 180 degree, at D point here 270 degree, and at E point it completes one wave. So this is going to be 360 degree, or this is 0 because again it is starting from this point, right? That way, where it ends, so this wave, suppose this wave is traveling from one instrument like this, it completes one wave, then it continues and it reaches at this point. So what is this phase at this point? That we can calculate. So that will be some, suppose at this f point 90 degree, at g point 180 degree already. Here it is 270 degree, and here it will be 360 degree. So in between 270 degree and 360 degree, we can calculate that is the phase at that point. Okay, so the phase of the wave will give us at which position the wave is at that particular moment. So we have this instrument, it is transmitting wave. We have a prism which will reflect the wave back to the original instrument, and then we will calculate how many numbers of waves has been completed and what is the phase difference at the final moment. Okay, that we will calculate. So here we are given the what is going to be the wavelength and what is going to be the relation between wavelength and frequency. This we already know, right? That if the wavelength is higher, the frequency is going to be lower. If the wavelength is smaller, just like in this case, the frequency is now increasing. Why? The frequency is increasing. The frequency has become 6 hertz. Why it has become 6 hertz from 3 hertz? Because the wavelength is reducing, right? Here again, we see the wavelength is further reduced. So definitely what will happen? The frequency is going to increase because this is the distance traveled in 1 second. The distance traveled in 1 second is going to be same because the velocity of the wave is same. But depending upon the wavelength, the frequency can be different. Here, the wavelength is larger, the frequency completed. The wavelength completed in 1 second is smaller. Here, the frequency is more. What it means? The number of wave completed in 1 second is more. So we have to remember that frequency and wavelength are inverse to each other. If wavelength is higher value, frequency will have lower value. If wavelength has smaller value, frequency will have higher value. Okay. Then the first one we have already discussed. Now this one, what will happen here? This was the first principle where we are calculating time. So distance is going to be v into t divided by 2, or this is going to be 2y because the distance is being measured twice. It is sent to the reflector, it is reflected back to the original instrument, then only we are calculating the distance. Therefore, the distance traveled is 2 times the distance between two concerned point A and B, right? The velocity, we will know, we know the constant velocity, and depending upon the environmental condition, the velocity may change a little bit and we can find it. The problem was what with calculating time, because the time is very small and it was difficult to calculate. Then we saw another procedure where what we are doing, we are calculating the phase. Now, again, the distance traveled is 2 times of d. Now, the distance traveled is given by 1. This way, the waves were going, right? And we are calculating the lambda is the wavelength. N is giving us how many waves has been completed and what is the final phase difference. Okay, so it will give us at the final moment what it happened. Okay, it is like this: how many numbers were completed and what is the final value. So it is till this point it was completed the wave and some more, say 90 degree, 95 degree, something like that. So that much it has traveled between these 2 points. That from that formula we will be able to find out what is the distance between point A and point B. So then here we have different, in this slide we have different electromagnetic distance measuring instrument. Okay, we have different instruments like geodimeter, then this instrument tellurimeter. Like that we have different instruments. We have electronic tachyometers, which is total station. We will be using it hopefully. So there, these all are using the principles of electromagnetic distance measurement. They all are using electromagnetic wave. Okay, they may be using different types of waves within electromagnetic wave, but the basic principle and the basic methodology is same for all these instruments. Now, the different types of instruments, depending upon what type of wave they are using, the instruments are divided into these categories. So microwave instrument, infrared instrument, and light wave instrument. So as the name says, microwave instruments are using microwaves. As simple as that. Then here we have an important concept. What is modulation? To measure the waves, we need to carry out modulation. Why we need to carry out modulation? Because the high frequency wave, remember when we saw the electromagnetic spectrum, there were some waves which were high frequency wave, and there were some waves which were low frequency wave. So this is the high frequency wave here. So when it is high frequency, the wavelength is smaller. This is low frequency. When frequency is lower, the wavelength is longer. Now, these high frequency wave, they cannot be used for measurement because of their smaller wavelength. Okay. Therefore, what we do, we use lower frequency wave for measurement. The lower frequency wave have higher wavelength, and it is easier to use these waves for the measurement process. The lower frequency wave. But the lower frequency wave, as the process of carrying out measurement, what happens if the distances is higher, they lose the energy. Okay, because these waves are electromagnetic waves, they have some energy, and these lower frequency wave, they lose energy quickly than the higher frequency wave. So the problem is that the higher frequency wave cannot be used because their wavelength is smaller, but they don't lose energy so quickly. But the lower frequency wave, they can be used for measurement, but they lose the frequency, they lose the energy quickly. So therefore, we combine them. This process is modulation. So one of the wave is used as carrier wave. Okay. This wave, high frequency wave, they are used as carrier wave. So what is carrier wave? They just carry the information. They just carry the data. What is this? Low frequency wave, they are measuring wave. So they have the original data of measurement. From the lower frequency wave only, we will be able to extract the data and find out the distances between the points. But those are carried by the high frequency wave. So when they will be modulated, so there will be two components, okay? The carrier wave and the measuring wave. And then after receiving the wave, they will be demodulated. Now they will be separated. The carrier wave will be separated from the measuring wave. And the measuring wave information will be collected from there only. So a modulation can be of two types, frequency modulation and amplitude modulation. When frequency modulation is done, if you see here, this is modulated wave. Okay? So frequency modulation has been done, and what happened? The frequency of the wave is changing. The amplitude is not changing. This is the amplitude, right? The distance from this mean position, that is the amplitude. The amplitude is constant, but frequency is changing. So when the frequency is changing, that is frequency modulation. When amplitude is changing, if we see here in this case, and when the amplitude is changing, in this case, the frequency is constant, but the amplitude is changing. So this is going to be amplitude modulation, okay? Then finally, after receiving, they will be demodulated, the carrier wave and the signal wave, okay, or the measuring wave will be separated, and measurement will be carried out based on the measuring wave or the original signal, as shown here. So even though we are using electromagnetic distance measurement, we may have some errors over there also, right? So there can be personal errors that are made by us. There may be errors due to atmospheric pressures and temperatures, which will influence the waves. There can be instrumental errors. There can be errors due to calibration, right? There can be errors on the reflectors. Okay? At this time of, okay, then there can be natural errors, etc. So even though we are using electromagnetic distance measurement, even though we are using a better technology, still there are possibilities of errors. But the advantage is that we have, much higher speed and much more accuracy than what we normally been doing, of course. Then total station is another instrument which is we use, and this is also using the principle of electromagnetic distance measurement. So total station is what? A combination of electromagnetic distance measurement and electronic theodolite. With the distance measuring, we can measure distance, and with the theodolite, we can measure angles, right? So they have both combined. So with the total station, we can do both distance measurement and also the angle measurement.